it. All right, guys. So any function with a variable in the denominator. All right, let me reduce the volume on here too. Sometimes the volume is too loud. Okay. If you can't hear me, guys, just let me know, okay? All right. Now, so guys, what you will notice is that there's a variable in the denominator. Once you see that variable in the denominator, the first thing you have to ask yourself is, what value should be excluded or restricted from the domain of the function? What value should be restricted or excluded from the domain of the function? In other words, what value will make the denominator equal to 0? Remember, the denominator of a fraction can't be 0. So whatever that value is, it needs to be restricted from being a part of the domain of the function. So for this particular problem right here, the restricted value, that value that makes the denominator 0, is actually 0. Remember, when the denominator of a fraction, guys, is 0, that makes the problem undefined. You cannot divide by 0. That's why it is a must for you to find the excluded or the restricted value, as in the value that makes the denominator of the fraction 0, so you can restrict it from the domain of the function. So the restriction on this one right here would be 0. X cannot be 0, because if you have 0 in there, it makes the denominator 0. Now, let me give you guys a couple of examples, because I did not notice these problems on the assignment. So here's the first example. Let's say you have f of x is equal to 2 over x minus 3. When you see these type of problems, the question, the answer box will be phrased like this. The domain is all reals. Remember, the domain represents all the x's, guys. As in, you can plug in any real value for x, except x cannot equal to what value? And your job is to go ahead and plug in that value that x cannot equal to. So the question is, what value makes this denominator right here equal to 0? Or you can ask this question, what number minus 3 makes it 0? Whatever that value is, that's the restriction to the function, or the restriction in the domain of the function. So this one, x cannot equal to 3. So this is what you would plug into the box for this particular problem. Now, if you're not sure, guys, just take x minus 3, set it equal to 0, and just go ahead and solve this to get x equals to 3. So there's your restricted value, all right? Now, here comes an additional example, number 2. F of x is equal to, this time, x plus 1 over x squared minus 4. What you will notice is that the denominator, guys, is a quadratic. And so since it's a quadratic, you should be thinking probably this is going to have 2 restricted values. So how do we find the restrictions in the domain? You take the denominator, set it equal to 0, and solve. How do we solve this? We factor x minus 2, x plus 2. Now, you ask the question, what number minus 2 makes this parentheses right here equal out to 0? And what number plus 2 makes this parentheses equal to 0? So there are 2 values, guys, which will make the denominator of this fraction 0. X cannot equal to positive 2. That's one of them. Or x cannot equal to negative 2. In other words, the denominator or the domain of this function can include every single x value except positive 2, negative 2. So the function is defined for every x except at x equals to 2, x equals to negative 2. So that's the extent of the functions, guys. Now, let me go ahead and move on to the next part of this. The next part is on simplifying rational, there's a G in there somewhere, okay? That's a G. Rational expressions. And when we talk about rational expressions, guys, this is a nice euphemism for fractions, basically. So when we talk about simplifying these rational expressions, think about this in terms of grade school. Back in grade school, you had problems like this, 12 over 18. And you had to simplify this fraction. To simplify this, you could go ahead and factor it. If we factor 12, we could rewrite it as 3 times 4. That's not completely factored into its prime factors. 18, we could factor it into 3 times 6. And then, of course, actually, you know what? Let me take it further out. 3 times 2 times 2, that's the 12. And for the 6, it would be 3 times 2 times 3. Now, what do you do next? You cancel out the like factors. So when we cancel out the like factors, we cancel a 3 from the numerator and a 3 from the denominator, a 2 in the numerator and a 2 in the denominator. So what are we left with? 2/3. So this would be the simplified form of that fraction. So we're doing the same thing, but this time we're dealing with algebra, guys. So when we go to algebra, the first step you have to do is to factor. Factor both, if possible, the numerator, that's an abbreviation, and denominator, okay? If possible. Sometimes you can't factor them, if possible. Next, number 2, you want to cancel out the like factors. And when you're canceling out the like factors, guys, you want to go ahead and cancel 1 in the numerator, 1 in numerator, and 1 in the denominator. So you have to cancel them out in pairs, okay? And when you do the pairs, you must have a factor in the numerator, a factor in the denominator, just like we did with the 12 over 16. We canceled out a pair of 3s, we canceled out a pair of 2s. And then the last step, of course, is to write the simplified form. All right, guys. So I am going to do 2 examples with you guys. So write the simplified form. Now remember, this is coming from assignment number 1 from module number 7. All right, guys. Number 1 is easy. I'm not going to do number 1. So I'm going to go ahead and start with number 2. All right, problem number 2, guys. Number 2 is x squared plus 9x plus 14. All of this is divided by x plus 2. Now, the numerator is a trinomial, which means it's probably factorable. So we're going to factor the numerator into 2 binomials. X squared factors into x times x, and then 14 also factors. You want to find 2 numbers that multiply to give you 14. Remember, they multiply to give you 14 and add to give you 9, okay? So the 2 numbers that multiply to give you 14 and add to give you 9 are 7 and 2. And of course, you want to keep the other factor in the denominator. So now your problem has been factored. What you will notice is that you have a repeated factor in the numerator and denominator. So you cancel out the repeated factor. And once you cancel out the repeated factor, what you have left over is just x plus 7. So there's the simplified form of the problem. It's right there. Questions on that one? No, nothing? All right, guys. Now remember, I'm only doing 2 examples because I want to expedite the process, all right? So here comes the next one. 2x squared, by the way, this one is number 5. 2x squared minus 7x minus 30 over x squared minus 9x plus 18. Okay. Now, guys, what I want you to notice about this one is that you got a hard trinomial in the numerator, easy trinomial in the denominator. So on this one right here, what we're going to do is factor the easiest one first. Which one's the easiest one? The one in the denominator. So we're going to factor the one in the denominator into two binomial factors. X squared factors into x, finds x. And in 18, you want to find two numbers that multiply to give you 18 and add to give you a negative 9. So what would those two factors be, guys? What would those two factors be? By the way, since the 18 is positive, and of course, the 9 is negative, you would have two negative factors. So what are two numbers that multiply to give you 18 and add to give you very good current? Negative 3, negative 6. There's your two factors. Now, since I started with the one in the denominator, guys, so now I am going to tackle the one in the numerator. Here's a nice hint for you. One of these factors in the denominator will appear in the numerator, okay? So I'm going to take a guess at which one it's going to be. How many questions are on the final exam? All right. I think the final exam has 30 multiple choice questions, Nicholas. All right. I'll make sure I verify it for you. I got to go check it again. All right. So right here, typically it has 30 multiple choice questions. So I'm guessing 30 multiple choice questions. I did not see it. I just got the email. I did not look at it, but I will be looking at it to create your DMC. All right, guys. So I'm going to guess it's the x minus 6. So if it's the x minus 6, that's one of the factors of this polynomial right there, then what I'm going to do is to figure out what binomial should I multiply, what binomial should I have here to multiply by x minus 6 to get back to this one. All right, so here's how I'm going to do it, guys. All right, so the question for this one right here, the question you should be asking yourself is, okay, here we go. What number multiplies by negative 6 will give you positive 30? Whatever this number is that multiplies to give you multiplies negative 6 to give you a negative 30 must go into the first parentheses. So that number would be, what would that number be, guys? Anybody? What number multiplies by negative 6 gives you a negative 30? Yes, Nicholas, positive 5. Okay, now, the next question is this. What number, okay, what would you multiply x by to get back to 2x squared? What do you multiply x by to get to 2x squared? We would multiply that by 2x, right? So guys, let's check it to see if it works out. We're gonna go ahead and multiply the 5 and the x together, that's 5x. And then we're gonna multiply the 2x and the negative 6 together, that's gonna give you a negative 12x. When you add them together, you do get negative 7x, so it works out. So the factors work out. So we've got our factors for the numerator. So now we have our factors for the numerator. We're going to check and see if we have any common factors in the numerator and the denominator. And we happen to have the common factor of x minus 6. So we're going to go ahead and eliminate x minus 6 from the numerator and denominator. And what are we left with once we eliminate them? 2x plus 5 over x minus 3. So this would represent the simplified form of the fraction. And that's it, guys. All right, so let me see here. So the camera is what is needed for the final. I came in late. Okay, all right. So Asha, this is going to work very similar to a test being administered in the classroom. Since we are not in the classroom, we are asking that you come into the Zoom session in order to be able to take the test. Once you come into the Zoom session, there will be a password, okay, on the test. And so I will release the password around 7 p.m. so you guys can work on the test. While you guys are working on the test, your mic doesn't have to be on. However, your camera needs to be on. All right, and of course, it will not be recorded, guys. Not. All right. So guys, give me a thumbs up if you are okay with simplifying the rational expressions. We're gonna be doing the same thing over and over again, by the way. All right, Austin gave me a thumbs up, one person. Okay, guys. So if you're a little lost with it, listen, I am going to be doing the same thing for the next two parts of this, okay? So just keep an eye out. You will get it by the time I'm done with all three parts. Okay, so guys, here comes the next part. And this one right here is multiplying the rational expressions. We are going to be multiplying the rational expressions. In other words, we're going to multiply fractions. Can we use notes on the test? Nicholas, you're not allowed to be using notes, but you're at home, Nicholas. That's all I'm saying. All right. So guys, here we are. When we are multiplying rational expressions, we're looking at problems like this. 3/5 times, let's say 10/9. That's a basic fraction. I see you, Sarah. Okay, that's a basic fraction. So because you are multiplying a basic fraction, guys, you can cross cancel, as in cross simplify. So in other words, you can cross simplify the 5 with the 10. You can cross simplify the 3 with the 9. So you would do something like this. 5 goes into 5 once. 5 goes into 10 twice. And then do the same thing with the 3 and the 9. 3 goes into 3 once. 3 goes into 9, 3. And then what do you do to finish out the problem? You multiply 1 times 2, that's 2. 1 times 3 is 3. So that's the simplified form, okay, of the product of these two fractions. Now, so how do we do it with algebra, guys? Here are the steps to do it in algebra. So in algebra, first, you can't forget it, guys. This is one of the feared F words, factor, both numerators and denominators, if possible. Sometimes it's not possible, okay? Next, number 2, you want to cancel out or simplify out like factors. And just like with the previous section, when you're canceling out the like factors, you do 1 in numerator and 1 in the denominator. In pairs, guys, 1 in the numerator, 1 in the denominator. Number 3, you're going to multiply and write the simplified form. All right, so there we go. Now, simplified form, let me erase that. That didn't come out well. Simplified form. All right, everyone. So I'm going to, again, do a couple of examples with you guys. Now, remember, you will definitely see one of these on the final exam, guys. So just make sure you're paying attention. And one last reminder, I am going to drop 3 of the lowest homework assignments from modules 1 through 9, whichever one is the lowest, okay? By the way, guys, let me just say this for you, okay? I am going to leave the assignments open until Friday the 24th. Friday the 24th. I'm writing myself a note right there. Okay, so all the assignments will be open until the 24th at midnight. And at midnight, they are going to close, so you will no longer have access, okay? So once you get your grade from the test next Monday, you would need to check and see what your average is in the class. And then you have to decide, okay? Do I want to go ahead and work some more on the assignment so I can pull up my grade? Or am I comfortable with the way my grade is right now? All right? Okay, everybody. So here comes some examples. This one right here is problem number 7. And number 7 is 5x plus 5 over 12x plus 24 times 3x plus 6 over 5x squared minus 5. Now, everyone, whenever you're factoring, okay, always be on the lookout for those GCF. Remember, the first rule of factoring is to look for a GCF. So what you will notice is that both numerators and both denominators have GCFs. So you want to factor out the GCFs first, guys. So for the numerator of the first fraction, there's a GCF of 5. If we factor out the 5 from 5x plus 5, we're left with x plus 1. Remember, 5x divided by 5 is x, 5 divided by 5 is 1. Now, we're going to go to the numerator of the second fraction. The GCF in the numerator of the second fraction is what, guys? What's the GCF? What do you guys think? Ooh, very good, Georgia. It's 3. So you factor it out. That leaves you with x plus 2. All right. So now we're going to go to the denominator of the first fraction. And this one has a GCF of 12. Okay. So we're going to factor it out. If we divide both terms by 12, that leaves us with x plus 2. And then last but not least, the denominator of the second fraction, if we divide each term by 5, that leaves us with x squared minus 1. All right, everyone. So now this x squared minus 1 can be factored into two binomials because it is a difference. Here, let me write this down on the side for you guys. That's a difference of squares. And because it's a difference of squares, we can factor it into two binomials. So this would be x minus 1, x plus 1. And so since we had to refactor this, I'm just going to cancel it out from here, okay? So this is the complete factors of that polynomial. Remember, guys, whenever you're factoring, you got to factor completely. So now I'm ready to start eliminating out the like factors. Remember, when you eliminate out the like factors, you do one in the numerator, one in the denominator. One numerator, one denominator. Okay, so here we go. We do this in pairs, guys. X plus 1 cancels out with x plus 1. Okay, let me use a different color here. And then x plus 2 cancels out with x plus 2. Furthermore, guys, we have these 5s. 5 cancels out with 5. And then we also have the 3, which can be divided into 12. So 3 goes into 12 4 times. Now, I want you guys to notice what's left over, what hasn't been canceled out. In the numerator, we don't have anything left over, but we need to have something there. So I'm just gonna go ahead and plug in a 1. Now, why are we plugging in a 1? Because, guys, you have to have a number such that when you multiply it by the numerator, it gives you the exact same thing right back, right? So on this one right here, the numerator is going to be 1, but in the denominator, we have a 4, and we have an x minus 1 left over. So here's our answer. The reduced form of this problem, okay? So take a moment, look at this one, and see if you have any questions. Do you guys have any questions? Okay, I'm going to do one more multiplication problem, and then we're going to go ahead and move on to division. Sarah's got a thumbs up. All right, thank you, Sarah. Anybody with questions? No? All right, guys, so let me go ahead and do this next one. This next one right here is problem number 9. And problem number 9 is x squared minus 5x minus 14 over 2x squared minus 98. Now, as you're writing this problem down, guys, you should be thinking about, how am I going to factor this problem, okay? You are finding the product of these two rational expressions. Remember, you got to factor both numerators and both denominators. As always, you have to keep in mind the first rule of factoring. What's the first rule of factoring? Is there a GCF? And so the numerator of the first fraction has no GCF. However, it is a quadratic trinomial. So we can factor it into two binomials. So we want two numbers that multiply to give us a negative 14. When we add them together, we get negative 5. So those two binomial factors will be x minus 7, x plus 2. 2 times negative 7 is negative 14. Negative 7 plus 2 gives you negative 5, guys. Now, in the denominator, there's a GCF of 2. So we're going to factor it out. When we factor it out, guys, okay, in other words, we're going to divide this by 2 and this by 2. That leaves us with x squared minus 49. This needs to be factored further. Why? Because it's a difference of two squares. So we can factor this into x minus 7, x plus 7. Now, since we had to factor this completely, I'm just going to cross this part out. Okay? So now I am going to move on to the second fraction. For the second fraction, guys, the numerator, you want to find two numbers that multiply to give you 49, add to give you 14. That's easy enough. So that would be x plus 7, x plus 7. It's the denominator you have to be careful with. The denominator is a trinomial. However, there is a GCF. The GCF for this one is 3. When you factor out the GCF, that leaves you with x squared plus 9x plus 14. Now, is this completely factored? No. This trinomial inside the parentheses, an easy trinomial at that, can be factored further. It can be factored into two binomials. As in two numbers that multiply to give you 14 and add to give you 9, those values would be positive 7, positive 2. So there's the complete factor. And since we had to refactor that, I'm going to cancel this out. All right, guys. So now we're done with the factoring. So now it's time to cancel out some like factors. So what we just finished was the hardest part of the problem. So now let's do the easy part of the problem, which is to go ahead and cancel out the like factors. And we cancel them out in pairs. One in the numerator, one in the denominator. So we got an x minus 7 in the numerator and an x minus 7 in the denominator. We're going to cross simplify next. X plus 7 with x plus 7. Furthermore, x plus 2 and x plus 2. Last but not least, we have an x plus 7 here and an x plus 7 there. All right, guys. So now that we're done canceling out the like factors, what would be the simplified version of this problem? You guys tell me. What's the simplified form? Do you guys see it? Go ahead. Anybody? Oh, you guys are lost. Okay. Oh, very good, Corinne. All right. Sarah's giving me a 2 plus 3. Okay. All right. So remember, this is multiplication we're talking about, okay? So you got to multiply. Now, what happens is that in the denominator, you have a 2 and a 3. So you multiply them together. This is a multiplication problem, guys, okay? Now, in the numerator, it seems like we canceled out everything. So what should we plug in for the numerator, guys? Am I going to 1/6? Yes, Yolene, I am going to 1/6. Very good. Sebastian, that is correct. 1 goes in the numerator. All right, guys. So that's the simplified form of this problem. So that was the second example. Give me a thumbs up if you're okay with this. And then we're going to move on to division, everybody. Okay, Corinne gave me a thumbs up. Leanne gave me a thumbs up. All right. I don't see any more thumbs up. Oh, Georgia, I see you. Okay, anybody else? Okay. All right. Now, I'm hoping now that we've gone through the second part of this, Sebastian, thank you, okay, that you notice, yes, guys, all right, this is very similar to the previous one we did, except we have more fractions to deal with. We're multiplying the fractions this time. Before it was just one fraction, we're simplifying it, but here we have to multiply 2 fractions. So guess what's coming up next? Division, of course. We're going to be dividing some fractions now. Can I do one more? Oh, yes, I can do one more, Sarah. You know what, Sarah? Hold on to that thought. Why? Because we are moving on to division. We are going to be dividing rational expressions, which is a form of multiplication. All right, so think back to grade school. Let's say we had 3 over 2, and we were dividing it by 9 over 12, something like that. Okay, I'm just making this up as I go along, people, okay? So in grade school, you had to keep the first fraction, change your division to multiplication. Here, let me use a different color here. Change your division to multiplication and reciprocate the second fraction. Now you could go about multiplying. Now, remember, you can always cross cancel if it's possible, okay? So 2 goes into 12, how many times? 6 times. 3 goes into 9, how many times? 3 times. And of course, 3 can go into 6, how many times? 2 times. So what are we left with? Just 2. So this is the same stuff you did back in grade school. Now we're doing algebra with this, guys. So here are some steps to dividing the rational expressions, okay? So here's step 1. Step 1, you want to keep the first fraction. Ooh, okay, there's fraction in there somewhere, guys. And multiply by the reciprocal of the second fraction. In other words, flip the second fraction, guys. Now, just to expedite this, number 2, I'm just going to say this, multiply the fractions. So use the same rules we used for the previous segment to multiply the fractions, you know. Factor the numerators and denominators. And then once you're done factoring, you want to go ahead and cancel out the like factors and multiply, write the simplified form, guys. So it's a very similar process. That's why I told Sarah to just hang on, because I am going to be doing the same thing again. All right, guys. So here's the example problem I'm going to look at with you guys, okay? It is number 12 from the assignment. And this one is x squared minus 14x plus 49 over x squared minus 3x minus 28. And then all of this is being divided by x squared minus 49 over 5. All right, guys. Time to factor, okay? Well, actually, we're supposed to keep the first one and multiply by the reciprocal of the second one. So I'm going to do 2 things at once. So the first thing I'm going to do is to factor the first fraction. So I'm going to factor the numerator, factor the denominator. All right, guys. So for the first one, what 2 numbers multiply to give you 49 and add to give you a negative 14? That would be x minus 7 and x minus 7. In the denominator, what 2 numbers multiply to give you negative 28, add to give you a negative 3? That would be a negative 7 and a positive 4. Now, here's the catch. We're going to change the division to multiplication. Here, let me put it this way instead. Okay, we're going to change that division to multiplication. And we're also going to reciprocate the second fraction. So the 5 will now go to the numerator. And in the denominator, you're supposed to have the x squared minus 49. But we're going to factor this. Since it's a difference of squares, we factored into x minus 7, x plus 7. Now we have our factors, guys. So now we can go about canceling out the like factors. So let's cancel out our like factors. So Sarah, as you can tell, this is very similar to multiplication. Essentially, division is multiplication, okay? So here we go. We're going to cancel out one factor in the numerator, one in the denominator. So x minus 7 cancels out with x minus 7 in the denominator. Now I'm going to cross cancel x minus 7 with x minus 7. Now I cannot cancel anything else out. So what am I left with? I am left with a 5 in the numerator. What do I have in the denominator? I am going to erase this equal sign here and move it over slightly to the left. What I'm left with in the denominator is x plus 4 right there. And then the x plus 7 right here. So guys, here's the answer. Here's the simplified form of the problem. All right. I am finally done, guys, with module 7, homework number 1. I didn't want to do a lot of division problems because division is multiplication all over again. So, any questions, guys? Okay, no questions? You sure? Okay, everyone. Okay, now module 7 appears to have 4 homework assignments, but some of them aren't easy though. All right, guys. So now I am going to move on to the next one. And the next one has to do with adding fractions with the same denominator, with a common denominator, okay? And this one is module 7, homework number 2. And we are adding rational expressions with a common denominator. In other words, the denominators are the same. They are alike. And when the denominators are the same, guys, that makes it so much easier to deal with, right? So here's the process for adding these problems that have the exact same denominator. So if they have the same denominator, number 1, you want to keep the denominator. Number 2, add or subtract the numerators together. By the way, I put addition here, but there's also subtraction in here, guys, okay? And then number 3, you want to simplify if possible. Some of them you can simplify and some of them you cannot. All right. So guys, I am going to go in, and this one is very easy, very brief. It's got 8 problems in it. So if you're going through module 7 and you haven't done any of the assignments yet, I would definitely suggest you do homework number 2 first, because it's very brief, all right? So here's the first example I am going to do with you guys, and that is problem number 3. And for problem number 3, it's 7 over xz to the 5th power minus 13 over xz to the 5th power. Now, what you will notice is that the denominators, guys, they are both exactly the same thing. Xz to the 5th power. So you keep the xz to the 5th power, and you just subtract the numerators. So 7 minus 13 gives you a negative 6. And that's it. So that was a piece of cake. All right, so let me do something that's a little bit more challenging. And this time I'm going to problem number 5. Problem number 5 is b squared over b plus 6, and then minus 36 over b plus 6. So for this one right here, guys, since the denominators are alike, I am going to keep the denominator, subtract the numerators. Now, remember step 3, I said simplify if possible. So for this one right here, I am going to factor the numerator. factor it, factor the numerator, factor. So that's a difference of squares, guys. This one right here, that's a difference of squares. So I'm going to factor it into two binomials, b minus 6 and b plus 6. All of this is over b plus 6. Now what you will notice is that you have a repeated factor, one in the numerator, one in the denominator, so you cancel them out. So we're going to go ahead and eliminate out the like factors, b plus 6 with a b plus 6. So what are you left with? B minus 6. And there you are. Ask me questions, guys. Anything? All right, so let's do one that's a little bit more challenging. All right, here's the one that's a little bit more challenging, guys. Okay, this time, this one is going to be number 7. Number 7. It is 3x minus 10 over x squared. And this is the last one I'm doing in this section, unless somebody wants me to do a different one. X squared minus 3x, no, 13x that is. Let me erase this. All right, there we go. Minus 13x plus 42. And then the other one is 3 minus 2x over x squared minus 13x plus 42. So guys, obviously the denominators are alike, so you want to keep the denominator, x squared minus 13x over 42. So now all you have to do is add the numerators together. Now, be careful. In the numerator, you have a 3x, which can be combined with the negative 2x. So that's going to give you x. Furthermore, you have a negative 10, which can be combined with positive 3. That's going to give you a negative 7. But the big question is, are we done? Of course not, we're not done. Here, you got to go ahead. No, Corinne, we're going to do that next. That's going to be the next homework assignment. If the denominators are different, you actually have to find the LCD. We're going to be doing that next, okay? Right now, the focus is simply on the ones with the like denominators. And this is the last one I'm doing. I know you guys are waiting to get to those, so I'm going to get to them in a minute, okay? Now, the denominator of this one is factorable. Two numbers that multiply to give you 42, add to give you a negative 13. So that would be x minus 7, x plus 6. So obviously, guys, we have a like factor in the numerator and denominator. So we're going to eliminate out the like factors as in x minus 7 and x minus 7. You cancel them out. So what's the final answer for this one? Okay, you have an x plus 6 in the denominator. So the numerator will be left with 1. Because 1 times x minus 7 is still x minus 7. It's not going to change it. So that's your final answer, which I circled there, guys. All right, so give me a thumbs up if you're okay with this one. This one was very straightforward, okay? The denominators are alike. Thank you, Corinne. They're alike. So what you do is you keep it, add or subtract the numerators, simplify if possible, like we just did with the last one, and then write the simplified form of the problem. All right, guys. So that was homework number 2 under module 7. Now let's go ahead and move on to the next one where the problems are a little bit more complicated, okay? Now, this is the ones where you have different denominators. Now, when you have different denominators, guys, that definitely complicates things, okay? So I am going to go ahead and go through this very quickly. It's got 13 problems. You just have to know the basics of adding fractions, adding, subtracting fractions with different denominators. Just the basics, okay? So guys, here we are. We are adding, subtracting rational expressions with different denominators. Now, just to recap, I'm going to go back to grade school. So in grade school, you guys had problems like this: 2/3 plus 7 over 12. Okay, I've had students who've done this. 9/15. Guys, that is wrong. 2/3, think about this, okay? 2/3 is slightly more than a half. 7/12 is slightly more than a half. If you were to add them together, you would at least get 1. The answer would be more than 1, greater than 1. If you tell me the answer is 9/15, 9/15, guys, is approximately, just a little bit more than half, okay? If you were to simplify this, you would get 3/5. So that would be 0.6. How can 0.6 be more than 1? That wouldn't make sense, okay? So where you just add 2 plus 7, 3 plus 12, no, don't do that. That's not how you add two fractions with different denominators. The first thing you got to do is to go ahead and find the LCD between 3 and 12. The smallest number that 3 and 12 can go into evenly. A multiple of 3 and 12, the smallest multiple of 3 and 12. In other words, if you were to count by 3, 3, 6, 9, 12, 15, and so forth and so on. If you were to count by 12, you'd have 12, 24, and so forth and so on. What do they have in common? The 12. So that would be your LCD. Now, I know some of you are saying, well, why can't I multiply 3 times 12 and get 36? That would work, but this is not the LCD. Nope, that's not the lowest common denominator. So guys, you got to find the LCD. Okay, now, additionally, if you change the numerator, you have to change the denominator. What you will notice for the second fraction is that you have the same denominator, so the numerator remains the same. However, for the first fraction, we changed it from 3 to 12. How do we go from 3 to 12? We multiply it by 4. So whatever you do to the denominator, you must do it to the numerator. 4 times 2 gives you 8. So now you have like denominators. So you keep the like denominator and then add the numerators together. So that gives you 15/12. But since we're dealing with fractions, if it can be reduced, you have to reduce it. And yes, this one can be simplified. When you simplify it, guys, it simplifies to 5/4. Okay, so that is what we're doing right here. Okay, so let me go ahead and give you the steps. Step 1. Hold on a second, I'm letting somebody in. Okay, perfect. Okay, guys, step 1, we're going to find the LCD. And the LCD stands for the lowest common denominator. All right? Now, how in the world do we find it? It is a product of the denominators. Now, you want to use repeated factors once. And this is very critical right there, guys. If you have a repeated factor, use it once. Now, how does that come into play with the previous problem when I didn't multiply the denominators together? Well, let me go ahead and show you guys. Okay, for the previous problem, guys, let's look. The denominators were 3 and 12. So I have a denominator of 3. Hold on, let me write it down here. 3, and then 12, I can factor it to 3 times 4. Now, following through with what I just said about the LCD, we want to find the product of the denominators. If there's a repeated factor, in this case, the 3, we got to use it just once. Use repeated factors just once. So then the LCD would have to be the repeated factor, which is 3. We're going to use it once, and then we multiply it by 4, so that would give us the 12. That's what I mean by it. All right, guys. So here comes the next step. Let me just erase this. So now, if you change your denominators, once you find your LCD, number 2, you want to change the numerators if necessary. If you change the denominator, change the numerators, guys. If you didn't change the denominators, then you don't need to change the numerators. Now, number 3, you want to keep the LCD, add or subtract the numerators. And then, guys, there's a last step, but I need more space to write the last step. Actually, you know what? Let me just erase it at the top here, and then we'll go ahead and write the last step, okay? So here is the last step, and that is step number 4. Step number 4 is to go ahead and simplify, if possible. If it's possible. Sometimes you cannot simplify them. And in order to simplify, you may have to factor. Very similar to what we did with the previous section. You may have to factor, guys. All right, so I am going to go through 3 examples with you guys on this one, and then I will leave this section alone, okay? I'm going to start with an easy one. Okay. Let's start with this one right here, number 2. All right, guys, number 2. Remember, I'm in module 7, homework number 3. It's 8 over 13y squared minus 7 over 2y. So the denominators are 2y and then 13y squared. Now the y squared, I'm writing it out as y times y. I have a repeated factor of y. So the LCD will be made up of the product of all the denominators. So that would be the 2, the 13, the y, the repeated y right there, and then the additional y. So when I multiply all of this together, it's going to give me 26y squared. That's my LCD. All right, I'm pausing here just in case you guys have a question. Ask me a question, anything. This can be a little confusing. Fractions tend to be somewhat confusing to students. All right, so since you guys don't have any more questions, I'm gonna move on, all right? So guys, we figured out that the denominator is 26y squared, okay? So now we're going to write down the new denominator, 26y squared for each fraction. If you change the denominator, you must change the numerator. All right, so we're gonna look at the first fraction. To go from 13y squared to 26y squared, what do we multiply 13y squared by? Well, we multiply it by 2. Whatever you do to the denominator, you must multiply, do the same thing to the numerator. So since we multiplied the denominator by 2 to get here, we're going to multiply the numerator by 2, so that becomes 16. Now, we're gonna go to the second fraction and do the same thing. We were at 2y, we ended up with a 26y squared. So to go from 2y to 26y squared, we multiply the 2y by 13y. So we're gonna do likewise to the numerator. So we're gonna do 7 times 13, guys. And 7 times 13, what does that come out to? 70 plus 21, that would be 91. All right, so now we've changed the numerators, so we can then keep the denominator 26y squared, and then subtract the numerator 16 minus 91y. And since this one has no y variable there, we cannot combine it with this one. So guys, this is our final answer right here, all right? That's our final answer, 16 minus 91y over 26y squared. Okay, if you're not quite getting it yet, just wait for about another example or 2, and you should start getting it. All right, guys, let me see here. Let me find something that's a little bit more challenging. Ooh, this one looks a little long. Yeah. All right. Okay, let's do this one right here. That's a little bit more tame. All right, number 9. The number 9, I've got 9 over 2x plus 2. Okay, so here I'm adding it to 2 over 3x plus 3. Now, when you're finding the LCD, guys, for this one, Sometimes you may have to factor, and this is an instance where you have to factor the denominators. May have to factor the denominator so you can find the LCD. All right. So this denominator, the first denominator, has a GCF of 2. When we factor it out, that leaves us with x plus 1. The second one has a GCF of 3. When we factor it out, that leaves us with x plus 1 as well. What you should notice is that there is a repeated factor of x plus 1. Remember, the LCD is a product of all the denominators, but when you have a repeated factor, guys, use it just once. So in this case, we're going to multiply 2 times 3, and then multiply it by the repeated factor. So 2 times 3 times the repeated factor. So the answer comes out to 6 times x plus 1. And there you are. All right. So now that we have the LCD, 6 times x plus 1, okay, we're going to change the numerators accordingly. Now, let's make the comparison. For the first fraction, we had a denominator of 2 times x plus 1. Now, the new denominator is 6 times x plus 1. So to go from 2 times x plus 1 to 6 times x plus 1, we multiplied this by 3. So we're going to multiply the numerator by 3. So 3 times 9 gives us 27. Now, we're going to do the same thing with the second fraction. We have 3 times x plus 1. We go from 3 times x plus 1 to 6 times x plus 1. We multiply this by 2. So we multiply the numerator by 2 as well. So 2 times 2 gives us 4. So now, guys, we can go ahead and keep the denominator, 6 times x plus 1, and then add the numerators together. 27 plus 4 gives us 31. Guys, this is the sum of those two fractions. Any questions? That was the second example, by the way. So you guys should be feeling a little bit more comfortable. Do we only simplify the numerator? Okay, we are not simplifying the numerator because right now we cannot simplify these problems. We're simply adding them together. We're combining them together. All right, ask me other questions, guys. Hold on a second. My dog is wanting to get in. Hold on, guys. Let me get my dog in. Hey, Mom. Come on in. Is the guy watching out there? All right, guys. So, questions, anything? No? Okay. Would you guys like another one? Give me a thumbs up if you would like another one. Ooh, okay. Sounds like you guys are tired of these fractions. Uh-huh. Okay, so nobody wants another one. Okay. So if you guys don't want another one, then I'm going to leave this section alone. I wanted to do 3 examples, but it sounds like you're done with adding, subtracting fractions. Yeah, they can be somewhat challenging. For some of you, might just be tedious. Okay. So let me go ahead and complete this section right here with the last one, simplifying complex fractions, guys. By the way, I did put up the attendance code on here. Did you guys see the attendance code? Make sure you guys do your attendance. Oh, Sarah, you just said I want another one. Oh, I do. Okay. Shazam, Sarah. Okay, Sarah, you're going to have to hold on for me until after I'm done because I went and moved on to the next section. I'm sorry, Sarah. I didn't see your hand there. I mean, your question. There's no hand. Okay. So hang on for me and I'll do another one after I'm done with everything else. All right. Okay, guys. So here comes the last section, the last homework assignment and module. Number 7, remember we're trying to get to module 9. The information in module 9, most of it we've already covered. It has to do with the linear equations and slopes of lines. However, there's one section on systems of linear equations which we did not get a chance to cover in this class. I will definitely not get to it. So what I'm going to do is create a Zoom video for you guys and upload the Zoom video for you guys on solving systems of equation by substitution and elimination. Now, guys, I am in the process of taking all the Zoom sessions and uploading them to YouTube because for some reason, Blackboard is not uploading the videos correctly. So once I'm done uploading all the current videos I have for you guys tonight, I will send you information on how to access them, okay? I will send you the YouTube links, all right? So moving along, here comes the last section, last homework, and module 7, homework number 4, guys. All right, we are discussing complex fractions, all right? Now, for the complex fractions, guys, we're looking at a fraction where both the numerator and denominator represents a fraction. So basically, it is a fraction where both the numerator and denominator contain fractions. So in other words, you have fractions within a fraction, all right? So a complex fraction might look something like this: A over B divided by C over D. This is a division problem, guys. A over B divided by C over D. So if it is a basic problem like this one right here, you have a division problem, all you have to do is keep the first fraction, change your division to multiplication, and reciprocate the second fraction and multiply, okay? But we wish it was that easy, and I can tell you right now, it's not that easy. So let me go ahead and give you some steps in terms of how to do it, okay? So guys, here are the steps. Number 1, you want to go ahead, here we go again. We have to find the LCD for all the fractions. Number 2, you want to multiply each term, every single term, guys, by the LCD. And the reason you're doing this is to simplify the fractions, to simplify the fractions out. Now, number 3, next, you are going to write the simplified form. Sometimes you may have to factor, All right. Now, these are complex fractions, especially if you've never seen this before. I am going to do 3 examples with you guys, okay? This one is homework 4, and this one right here is 12 problems long. By the way, guys, I just checked into module number 8, and module number 8 is actually something we've already covered. So we are good with module number 8, homework number 1, and I'll mention it in a minute, all right? So here comes the first example, and the first example right here, guys, is 12 over 7x divided by 3 over 7x. Now I'm going to work this out using the steps that I just gave you. So the denominators, guys, are 7x, okay, and 7x. Since the denominators are alike, that becomes the LCD. So we're going to multiply every fraction, every single term, by the LCD. So what ends up happening, remember we're simplifying the fractions out. You can put the 7x over 1 if you want to. So in other words, you're multiplying two fractions. So then the 7x cancels out with the 7x in the numerator, leaving you with 12. And the denominator, the 7x's cancel out, leaving you with 3. So now you're just left with 12 over 3, and 12 over 3 will simplify to positive 4. And there's your answer. Now, here's another way you could have done this one. Because it's such a simple problem, you could have actually done this. This problem is 12 over 7x divided by 3 over 7x. So in other words, it's a division problem. So which means you can keep the first fraction and multiply it by the reciprocal of the second fraction. So in other words, flip the second fraction. So here, what happens, I am going to cancel out the 7x's, cross cancel them out, cross simplify. So I'm left with 12 over 3, and 12 over 3 is 4. And the only reason we can do this one like that, guys, is because it's an easy problem. Any questions on this one? All right, guys. I am going to look for another one. Let's see here. Ooh. All right, so let me go ahead and do this one right here. And for this next one, guys, it's a little bit more complex, but we can do it. And this one that I'm doing right here is problem number 5. Now, for problem number 5, it is 4x squared minus y squared over xy. And the denominator of this complex fraction, we have 2 over y minus 1 over x. Now, what are the denominators? The denominators are y, x, and xy. So if we're finding the LCD for this one, remember, is a product of all the denominators. When you have a repeated factor like x, use it once. When you have a repeated factor like y, you also use it once. So there's your LCD. Once you find your LCD, you're going to multiply everything, guys, by the LCD. So every single term gets multiplied by the LCD of xy. Every term by the LCD of xy. Okay, there's a y here, okay? Everything multiplied by xy. Now, let's simplify. Okay, so if we're multiplying the numerator by xy, guys, okay, again, if you want to put a 1 over here, you can. Cross simplify the xy's out. So that leaves you with 4x squared minus y squared. And the denominator, the y cancels out with the y, leaving you with x times 2. So you get 2x. And then over here, the x's cancel out, leaving you with 1 times y, which is 1y, or just y. But wait, we're not done, guys. There's more. So next, we're going to have to simplify this. This needs to be simplified. What does that mean? The numerator can be factored because it's a difference of squares. So we're going to factor it into 2 binomials. 2x minus y times 2x plus y. And the denominator is 2x minus y. Now, what you will notice is that we have a like factor in the numerator and denominator. So we're going to go ahead and cancel that. So we're going to cancel out the 2x minus y with the 2x minus y. And that leaves us with 2x plus y. And this is the answer for this problem. All right. I'm taking a pause so I can take some questions from you guys. What questions do you guys have? What questions? Anything. How you doing, Lisa? Any questions, guys? No? Okay. So give me a thumbs up if you want another one. And remember, I just did assignment number 4 on the module 7, guys. Give me a thumbs up if you want another one. Okay, Corinne says I want another one. All right, Corinne, let's go ahead. Yeah, one more, please. Okay, Yolene, we're gonna do another one. So let me find a good one for you guys. Now it's number 5 I just did. So let me look for a good one. I was looking for one that would be similar maybe to a final question. Question on the final exam, but I'm not seeing one. Okay, so I'm just gonna go ahead and just grab something. Okay, I think I'm gonna do this one right here, guys. All right, let's do this one right here. Number 10, we're going to do number 10. All right, everyone. Now, number 10. For number 10, I've got x over 36 minus 1 over x. Okay, and all of this is over 1 plus 6 over x. That's 1 over x. Ooh, hold on a second. Let me fix that. That's supposed to be a 1 right there. All right, guys. So the denominators are, okay, x, and 36. So the LCD is a product of all the denominators. And when you have a repeated factor, you can only use it once. And so since the x is a repeated factor, we're going to use it once. And the 36 is not a repeated factor, so that will become part of the LCD. So the LCD for this one, guys, is 36x. Now, this problem has 1, 2, 3, 4 terms, guys. 4 terms. It's got 4 terms. Every single term must be multiplied by the 36x and simplified. So I am going to multiply each term by 36x. So every term multiplied by 36x. Every single term by 36x. Every single term by 36x. Every term by 36x. And now I am going to simplify. So here I go, guys. All right. So on this one right here, I think I am going to go ahead and get started in the numerator. Okay, so in the numerator, the 36 cancels out with the 36. So x times x, that's x squared. So the first fraction simplifies to x squared. Now, second fraction, the x cancels out with x. So that leaves me with 36 times the negative 1. 36 times negative 1. And 36 times negative 1 is negative 36. Right here, guys, there's a negative 1 right there. Because this is a negative sign right there. All right, so now I'm going to go to the denominator. In the denominator, this is 36x times 1. So I get 36x. And then for the second fraction in the denominator, I'm going to eliminate the x's. So I have 6 times 36. 6 times 36 is 216. But wait, we're not done. There's more to this problem. We can factor the numerator into 2 binomials because this is a difference of 2 squares. So we get x minus 6, x plus 6. The denominator, guys, has a GCF of 36. So you want to factor it out. When you factor it out, 36x divided by 36 leaves you with x. 216 divided by 36 leaves you with 6. Now, what you will notice is that we have a common factor in the numerator and denominator. So we're going to simplify it out, the x plus 6. So what are we left with? We're left with x minus 6 over 36. Now, I know some of you may be tempted to eliminate the 6 or simplify the 6 with the 36, but you can't do that. Because in the numerator, you have a binomial. You cannot cancel out part of it and leave parts of it. Either you cancel the entire binomial out, or you do not cancel any parts of it, guys. All right? So that's the extent of the complex fractions, guys. They are just what they sound like. They are complex, okay? Plain and simple as that. Okay, so that was the third example. And yes, guys, are you going to see this on the final exam? Yeah, that's going to show up on the final exam. And yes, the final exam is going to be multiple choice. All right, any other questions before I move on? Okay, I'm almost there, guys. Almost there. It's about 8:10. I'm almost there, okay? Now, here's some good news you can use, okay? We are moving on to Module 8. Module number 8 has 2 assignments, okay? Homework number 1, we actually talked about it earlier, all right? I was doing this in order, so we talked about it. That was the rational functions, guys. And so since we've already talked about the rational functions, where you have to find what value needs to be restricted from the domain of the function, I am not going to discuss this. Rather, I am going to move on to the next assignment, unless somebody wants me to do an example. All right, nobody wants me to do an example? Just as a reminder of what the rational functions are? Okay, yes, ma'am. Okay, that sounds like you want me to do an example, Mr. Bregado. Yes, okay, do it. All right. Say no more, say no more. I'm about to do a couple of examples, or maybe he just wanted one. Okay, let me not get carried away right here. All right, so let me go ahead and do this easy one right here. This one is problem number 6. It is C of x equals to x plus 4 over x squared minus 9. And remember, guys, they will ask you to find the domain of the function. So they'll say the domain is all real numbers. All real numbers, except what? As an x cannot equal to what value? What value makes the denominator equal to 0? Whatever those values are, you need to restrict them from being a part of the denominator, guys. So what we do is we take the denominator, set it equal to 0, and solve. So the denominator is x squared minus 9, set it equal to 0. Now, how do we solve this? We factor. It's a difference of squares. There's other ways you could solve this too. You know, add 9 to both sides, take the square to both sides. But the problem is some of you might not remember those 2 answers, okay? So it's better to factor. X minus 3, x plus 3. So here's the question. What number minus 3 makes it 0? Positive 3. So that's one of the restrictions. What number plus 3 makes this parenthesis 0? Negative 3. So there's your 2 restricted values. X cannot equal to 3, or x cannot equal to negative 3. All right, guys, here is one more. And this one right here is problem number 4. Okay, for problem number 4, I've got f of x is equal to 4x over 2x plus 7. And again, this is all about the denominator. You need to restrict that number that will make the denominator 0. Define what that value is, set the denominator equal to 0, and solve. See, I'm just solving the denominator, guys. 2x equals to negative 7. That's an equal sign there. And then I divide both sides by 2. So the value that will make the denominator 0 is negative 7 over 2. And since it's going to make the denominator 0, you want to restrict it from being in the domain of this function. And yes, guys, you will definitely see this on the final exam. Absolutely. All right. So any questions about this one, guys? Okay, so then let me go ahead and try to finish out the night. And that is solving rational equations. So all the problems we've been doing have been expressions. So now we're looking at equations, meaning these problems, they now have an equal sign in there. So you have to find the value that will make the problem true. So here's an example, guys, of a rational equation. This one is problem number 11 in the same assignment. So on this one right here, the first step is to go ahead and find the LCD. And we just finished talking about the LCD. Guys, what's the LCD between 2 and 3? I know you guys are getting tired, but the sooner you answer, the sooner we can go ahead and end the session. What's the LCD? 1, Sarah, come on. The LCD between 2 and 3. Come on now, okay? It's between 2 and 3. That's 6, okay? So guys, once you find the LCD, all right, Sarah. Once you find the LCD, you want to go ahead and multiply each term by the LCD to eliminate the fractions, guys. All right, there we go. Now, we're going to multiply the 12. Okay, we could just put a large bracket around the entire problem, but I'm going to do it right next to each term, guys. Multiply every term by 6. Every single term gets multiplied by 6. Okay, now guys, we're going to eliminate the fractions. So for the first one, okay, here it goes. So on the first fraction, 2 goes into 6. How many times? That's the question. 2 goes into 6 3 times. So we take the 3, multiply it by y. So we get 3y. Next, for the second term, 3 goes into 6 2 times. As in 3 times what number gives you 6 is 2. So you multiply the numerator y by 2. So you get 2y. And then guys, last but not least, you multiply 12 times 6, which gives you 72. Now, once you're done eliminating the fractions, look at how easy this problem is. Okay, step 3, solve the equation, guys. And this one just happens to be so easy. All we do is 3y minus 2y. That gives us y. Y is equal to 72, and we're done. But there's one more step, and this is a critical step right there. You want to make sure you check the solutions. Check the solutions, okay? And why are you checking the solutions? Because you want to make sure the solution makes the original problem true. If you find a solution that doesn't make the original problem true, refer to it as an extraneous solution. You can't count it as a solution. You must reject it. And so, if it's the only solution, then the problem would have no solution. If for some reason, guys, you have another solution, you have 2 solutions, one of them makes the problem true and the other one makes the problem false, whichever one makes the problem true, that's the one you want to keep. The other one that doesn't make the problem true, you want to reject it, throw it out, okay? So the solution set for this one right here is just the 72, everybody, right there. Let me go ahead and underline it for you, just in case you did not see it, right there, y equals to 72. That was too easy. So let me go ahead and grab some additional problems for you. Okay. Now here's one that is super easy, which you do not need to make complicated. And this is number 13. I've got x squared plus 1 over x equals to 17 over x. So in this one right here, guys, what you will notice is that the denominators are equivalent to each other. So if the denominators are equivalent, that makes the numerators equivalent to each other. And then we solve it. So we're going to subtract 1 from both sides. So you had x squared is equal to 16. You want to take the square root of both sides. Now remember, guys, when you take the square root of both sides, you always get a compound solution. So you're going to end up with plus or minus 4. So this one has 2 answers. So when you're typing in the answer for this one, if you don't type in both solutions, guys, the computer will mark it wrong. By the way, number 13 is very similar to number 14. Similar to 13, guys. Similar to 13. All right, next one. Number 15. For 15, I've got 6 over x plus 2 is equal to 5 over x minus 2. Now, for this one right here, we have two equivalent fractions. When you have two equivalent fractions, we refer to this as a proportion. When you have a proportion, you can go ahead and cross multiply it in order to solve it, guys. So this is going to expedite the process. Instead of having to multiply everything by the LCD, which you could do, okay? But one way to handle this problem is to cross multiply. The only time you can do this is if the two fractions are equivalent to each other. If you have two fractions that are equal, we have a proportion, so you can just cross multiply it. 5 times x plus 2, and then work it out. So 6 times x, 6 times 2 gives you 6x minus 12. And then 5 times x, 5 times 2 gives you 5x plus 10. Subtract the 5x on both sides. So that leaves you with x minus 12 is equal to 10. Now add the 12 to both sides. So you get x equals 2, 22. So there's your answer. Now, I haven't been checking my solutions, but if I get to one, guys, where we should be checking the solutions, I will go ahead and definitely do that, okay? Any questions? No questions? Okay, sounds like you guys are ready to call it a night. Okay, all right, one last one. Let me see here. Okay, yes, I do need to mention this one. Okay, this one is number 21, guys. This one, because you have the variable in the denominator, you have to be concerned about the restricted value in the domain of this function. The restricted value is -2. X cannot equal to -2. So keep that in your head. Now, what you will notice about this problem is that the denominators are equivalent to each other. They're the exact same thing. So if the denominators are equal, that makes the numerators equal to each other. Then you go ahead and solve it. Now, here's why I'm bringing this to your attention, guys. When you solve it, what do you notice? This answer is the restricted value. Since it's the only solution, it's the restriction. You're not allowed to have x equals to -2 as a solution. So we're going to reject this and say this one has no solution. So for problem number 21, I think everybody ends up with a similar outcome. There's no solution for it. So you guys might want to write a note next to that. For problem number 21, there is no solution to it, guys. All right, so here's where we are. We are at 8, let's see here, 25, Shazam. Okay, now the second lesson in module 8, we're supposed to be solving rational equations, all right? And some word problems involving rational equations. Formulas involving rational equations, and then some word problems, guys, okay? So what I'm gonna do now is do a couple of word problems, and then I'm gonna let you guys go, okay? Because I know you guys are tired. So let me just do 2 word problems, and then we'll be done with this. And this one, they are easy, Shazam. These word problems are easy. Okay, let's get to work so I can get you out, so I can stop talking too much, okay? Module 8, guys. Module 8, homework number, this is from homework number 2. And this is the last thing I'm doing with you, okay? I'm gonna do 2 word problems. They are so easy, okay? Piece of cake, and then we'll be done. Okay, number 6, here's the first one. It says a camel can drink 15 gallons of water in 10 minutes. 15 gallons in 10 minutes. Now think about it. If he's drinking 15 gallons in 10 minutes, how much water can he drink in a minute? About 1.5 gallon every minute, okay? Now, your job is to calculate how much water can this camel drink in 12 minutes. How much water can he drink in 12 minutes? What we have here, guys, is a proportion. As in 15 is to 10, as x, the number of gallons, is to 12. Now, how do we solve a proportion? I just mentioned it. You're gonna cross multiply and solve it. So you get 10x is equal to 15 times 12, which is 120. Divide both sides by 10. So you get x is equal to 12. Or you could have just done this, guys. Let me see here. Did I make a mistake somewhere? I feel like I made a mistake somewhere. Okay. Yeah, that's wrong, guys. This is not 120. This is actually 180. Okay, so fix that for me. So this should have been 18. Now, another way you could have done this is to take the 1.5 and multiply it by 12. Shazam, that's still the same thing, guys. Look at that, right there. Okay, same thing. That's number 6. That's the one out of the 2 word problems I'm doing with you. So let me go ahead and grab the other one so I can let you guys go, all right? Okay, next one, number 7. By the way, when you guys are doing these problems, make sure you're careful with the rounding because they do want to you to round this to a certain value. Like this one that we're doing, number 7, they want you to round it to the nearest whole number, the nearest whole number. Okay, so number 7, 14.2 out of 50 employees in a company were women. Your job is to figure out if the company has a total of 41,970 employees, how many of them were women? This is another proportion, guys. So you're going to cross multiply it. So you're going to get 50x is equal to 14.2 times 4197 0. Okay, and then divide both sides by 50. Somebody grab a calculator, please, so you can do this for me very quickly, since this is the last problem, so I can go ahead and let you go. 14.2 times 41,970 divided by 50. And somebody give me the answer for that one, because that was the last problem. Why would there be a restricted value? Or is that just something the test would do? Okay. Let me see. Hi, I'm sorry, my internet. Okay, that's fine, Austin. All right. Whenever you're dealing with rational, and rational means fractions, okay? Rational equations or rational expression, meaning you have a variable in the denominator, Sebastian, you should always be on the lookout for the restricted value. What value will make the denominator equal to 0? Because if you solve the problem, you get a value that will make the denominator equal to 0, you cannot count it as a solution, okay? You don't want the denominator of the fraction to be 0. You want every value that you find for an equation to make the original problem true. So that's why you should always be on the lookout for those restricted values. All right, did anybody plug this? Oh, yay, somebody plugged it into a calculator. Now, the only problem is we have to round this to the nearest whole number. So Georgia, thank you for giving me that decimal, but I am going to round it to the nearest whole number. So this would be 11,919 women in this company. And guys, that was the last problem. Thank you for coming. If you have any questions, please go ahead and